what I believe now is this next generation of hybrid engineers that you guys are becoming need to have the skills to translate between the traditional network domain and the software and application developers that we are increasingly running into. So the skills that I believe are useful to you as a network engineer when you're thinking about branching out.
That was Jason Davis, a distinguished engineer for Cisco on the Advanced Services team. In this episode of the Cisco Learning Network Podcast, find out what skills Jason thinks are the most important when starting out in network programmability. Jason also provides an introduction to the world of network programmability and looks at how the evolving network landscape has brought us to this point. Jason recently spoke in a CCIE CCDE Evolving Technologies Training webinar hosted by the Cisco Learning Network, and begins by giving an overview of SDN controllers, APIs, scripting, automation, and orchestration.
So to get started, the question is, what is software-defined networking? And I've talked about this for about 5 years now, and hopefully you're getting a good sense that, SDN is where things are going. I mean, we're decoupling control plane and data plane. We're putting the intelligence in a more central state so that we can manage one device rather than thousands, or if you're one of my larger service provider customers, hundreds of thousands of devices. It's also helping us to abstract and virtualize those components. And a lot of what we're seeing in the last 5 years is this move to a lot more programmatic interfaces, like REST APIs and things of that nature. I kind of joke that we're moving from finger-defined networks, or FDN, to software-defined networks, SDN, because we don't have to default route right to our terminal emulator like PuTTY. We can start to leverage these cool programmatic interfaces to make the network bend to our will as far as how we configure it and extract data from it to make better business decisions. SDN, if you weren't aware, came around about 2008 from Stanford University, and Cisco and Deutsche Telekom and a few other companies got together with the school and said, hey, we're going to create this program, we're going to call it Clean Slate.
Stanford University's Clean Slate Internet Design Program was a research initiative created to rethink the global communications infrastructure. This led to the emergence of the Clean Slate Lab, where anyone from professors to students to research staff and even engineers deployed prototypes of program ideas in research and operational networks. The program's executive director, Guru Parulkar, put it this way. He said, "The goal of the Clean Slate program is to reinvent the internet and to meet the needs of the future through fundamental and disruptive advances rather than incremental patches and workarounds." However, the program ceased to exist in January 2012. Stanford released this statement in its research overview. Though the mission was well-defined, the potential approach was not. We began with a number of small exploratory projects that led to a few flagship projects that show a lot of promise.
So what would it be like if we took 20 to 30 years of hindsight of building networks and just said, let's set that aside and build this over from scratch, right? So what we saw is a lot of focus around the separation of control plane, data plane. In a traditional network, and the way it was created was to have each device operate autonomously, right? It didn't rely so much on another device. It could have an adjacency with the other device, and its control plane, the brains of that device, would be able to make routing decisions, which is the best path through this network. And then the data plane would be programmed to execute on the rules of that decision, right? So separation of the brains and the brawn here, if you will. Being the brawn, being the data plane that moves the packets around, but the control plane, the routing operating systems, the BGP, OSPF, making decisions, those were initially meant for every device to have its own intelligence. But then to the SDN purist, the idea was to have this master control processor, if you will, or control plane, I should say. And all of the decisions and programming would happen at that controller, right? So then the network turns into essentially dumb plumbing and just moving packets around with no intelligence. And the control plane or controller would make all those decisions. And some of the early invocations of those controllers weren't all that sophisticated. They didn't really take advantage of 20 to 30 years of hindsight. As a matter of fact, some of the initial SDN implementations did things such as write rules that if there is no path for this traffic, just drop it instead of sending it up to the controller. So you can imagine that it could turn your network into a very effective firewall if you didn't fully populate all of the network with routing rules, right? Now they're becoming a little bit more sophisticated in some of these SDN protocols, in that if there is no rule already in that device, they will push those requests for traffic flows back to the controller, and the controller will say, okay, let's make a decision here about which way to send the traffic. Now, Cisco tends to have a bit of a hybrid approach at times, and you can see this through our history, especially if you have some experience in our wireless equipment, that initially we had access points that were autonomous, right? The brains were in each of them. You had to talk to each one to program it and to do software updates, and it was operating by itself. Then we kind of moved to a centralized approach with the wireless LAN controller, WLC, and then the access points were dumb, essentially, right? And then we kind of had this hybrid approach where you had like the Catalyst 3850 closet switch that kind of had some controller capabilities to serve the access points that connected to it. So we distributed that around. And so now we're kind of seeing the need to have a central configuration point, but still have some survivability with intelligence in the network. So it isn't always a black and white relationship. There are several protocols that we see in the network. Some of the technologies that you hear about, like Puppet, NetConf, or Net Configuration from the IETF working group, these things are handled and address different capabilities. So, Ansible's great. Love working with that, but that's really helpful, in a management and configuration traffic kind of perspective. There are other capabilities when you think about path computation element protocol and interface to routing system I2RS that get deeper into the control and forwarding of traffic. Recognize that, several fishes in the ocean here, and different protocols will generally do different things in our architectures. And we may end up deploying multiple pieces of these tools in our architectures as we try to have a robust environment. So I get asked quite often, Jason, are all of our network engineers becoming programmers? And if you had asked me that, 5 years ago when we started the road to SDN, I kind of would have laughed and said, no, not all network engineers are becoming programmers. What I'm hearing more and more, however, is that some of the executives at the companies that I call on will say, look, we're not replacing network engineers with network engineers. We're replacing them with people who have some programming skills. And so that allows them to distinguish themselves. It's a bit like if you've been involved in the early days of IP telephony back in around 1998 timeframe, that, we had the old tip and ring telco guys sitting across the table from us packet switch guys, right? The initial parts of IP telephony really didn't take off because we didn't have anybody to translate between the camps, right? And so it was the engineers that were willing to learn a little bit about the tip and ring telco business to translate that into what we needed for packet switch that were able to distinguish their careers and make this work for us, right? What I believe now is this next generation of hybrid engineers that you guys are becoming need to have the skills to translate between the traditional network domain and the software and application developers that we are increasingly running into.
In episode 3 of the Cisco Learning Network podcast, Salman Asadullah discusses the role of this hybrid engineer that Jason just referred to, and how traditional networking cannot keep pace with the demands of digital business. Salman talks about how there are new requirements coming in from the customers because of how data is being collected, stored, and analyzed. They want to do these things at a much faster rate, increase utilizations from the bandwidth perspective and from the resource perspective. And now, because of these requirements, the traditional methods of networking need to change. If you'd like to know more about the specifics behind what the responsibilities now are for these hybrid engineers, be sure to check out episode 3 of the Cisco Learning Network podcast.
So the skills that I believe are useful to you as a network engineer when you're thinking about branching out, learn a little bit about some basic programming constructs. Python is becoming a really good skill to have. I would have said, maybe 10 years ago, Perl, because Perl is a great programming language, if you will, for manipulating strings. And to be honest, that was a lot of what we were doing with configurations, was manipulating text configs. right? But we're also seeing now that people want to interface with APIs of their network management tools and other network services. So Python has some great capabilities for libraries to talk with web services, and we're seeing some embedded support for Python in our data center equipment. So I think if you're starting out, just go on and learn Python at a fairly rudimentary level, and then that will help you in rapid provisioning and data extraction of your equipment and give you better insight to the developers that you may be working with. Generally, web services are also a really good skill to have. It's always been good to have some regular expression capability or regex. Like I said, with manipulating text configs or show command output, being able to pattern match output is a good thing, filtering and searching. Data encoding is the next one. XML, XSL transforms of that XML data, and probably my favorite data encoding method, can you guess? JSON. Okay, that was a good joke. All right, basic database work, SQL, being able to do some shell scripting, some light database work with like time series databases. MySQL is a good open source database. And potentially if you're getting into some forms and user interface stuff, the being able to know a little bit about JavaScript is also helpful. But I believe the number one skill that we need as network engineers is being able to talk with the programmers, okay, effectively, telling them how networks work and using language that they're familiar with. Because what we find out, if we just set the programmers that have no networking experience off and say, go provision this service for me, they'll have to learn a lot about how to program VLANs and VRFs and such. And they may not understand all of the techniques that are necessary. They may not understand, what a routing table is or a MAC address table, ARP cache. And they might just assume the techniques they use as programmers would be effective when doing network programming. Oh, as a programmer, I'm out of memory. How about I erase everything that's in this ARP cache? That's using up a lot of space. Well, we know that would not be an effective thing to do. So we need to be able to advise them what are the hot buttons in networking and then use terminology that they're familiar with. We have some specialist certifications that are available to you. Network Programmability Developer and Design and Implementation are two specializations that I worked with the team on, and pretty excited about these opportunities to help people branch out a bit from standard route switch engineering. What you'll see is Network Programmability Developer and Design. These are two different type of courses that you can access. There's some prerequisite training that might help you programming for network engineers. If you're interested in that, I recommend hitting the Cisco Learning Network to access those pieces of information.
To hear more from Jason Davis or to view the full webinar that this segment is from, be sure to visit the Cisco Learning Network at www.ciscolearningnetwork.com. You can also visit the link in the description, which will take you to more training videos hosted by the Cisco Learning Network that lay your foundation for CCIE and CCDE Evolving Technologies. There are also links in the description that will direct you to the training courses Jason mentioned. The Cisco Learning Network contains all kinds of resources to help you get started on your networking career, including additional training videos and study groups that allow you to connect with others trying to get started in their networking careers. Please subscribe to the Cisco Learning Network podcast and be sure to leave us a review on iTunes if you found this helpful. Thanks for listening.